Hello, this is Clayton Balmas, and I'm your teacher today here in our audio classroom here with SynMax University, available at synmaxperformancelubricants.com. Today we're going to be sharing with you what I consider the crown jewel presentation for the SynMax Performance Lubricants line. It's the Diamond-like Additive Performance Data Presentation. And so I hope that you enjoy listening to this as I enjoy sharing this with you. And so let's go for a ride and see what we can find out. Okay, here we go. This was a solid lifter metal surface. Okay, and it's going to show fretting on the left versus pretty much brand new. Now, what happened was both of these motors were run with 530 oil. I'm not sure. A NASCAR engine. Okay, we're talking like it was actually a 800 horse engine. It was a dyno run, and so it simulated in the dyno for 600 miles or 700 miles of operation. But here's what happened. On the left, the lifter on the left had micro fitting on the surface wear. Now this was from frictional heat. Okay, you see the crown that was there? See where the cam would stroke on the side, then it would hit the crown, then it would come off of, of the of the lifter. Now that's similar to a piston crown, and that's called fire flash degradation. All right, and then on the right you see the oil with the PolyX technology and the DLA technology. This lifter was like brand new. Say, does that make a difference? Well, we've got guys in short track racing that run about anywhere from 800 to 1,000 miles a year, and they're on their third year on their lifters. So the oil almost paid for the lifter. The cam's $1,500 and the lifters are 500. You're buying technology. You're not just buying a bottle with a label. All right. Now you can see the lifter on the right, the DLA additive allowed the surface to operate cooler with greater protection. How's that evident? Watch this. Now this is very interesting. Here's 50 times magnification of the lifters. Now the lifter on the left has what we call microfretting surface wear. It's from frictional heat or heat oxidation, which means thermal breakdown of the metal surface. Similar to a piston crown, the terminology is called fire flash degradation. What's actually happening is that these lifters are very expensive metal machining to get them to the point to handle what they do. I mean, you can see the machining scars that they do, and the reason they have those machining scars, like on the right, is so that those cross hatches are able to hold the oil, and then the oil that's held is supposed to protect that surface. So the additive package on the left obviously was not sufficient enough to do it. I might say, Clayton, I know what it is. You must have had your 1,500 points high zinc on the right, not high zinc on the left. That is not true. Both of these had a racing additive package. The one on the left and the one on the right. They had the same amount of zinc, I'll tell you that right now. But the one on the right also had an Aerospace synthetic zinc along with it for higher temperatures to run cooler. The one on the left would have had moly, probably 1,000 parts of moly and maybe 13 to 1,500 parts of zinc. The lifter on the right would have had the diamond-like additive package, the synthetic zinc, and multiplied together, it was over the 1,500. But this showed additive technology at the subsurface level. All right, because obviously something worked on the right. Now here you're going to see the metal fretting coming through. Now we're not coming against any company, but if these were your lifters, You really couldn't reuse the ones on the left, but you could reuse the ones on the right. Again, the lifter on the left, you could see where the metal started getting hot. It was exposing, it was opening up, and as the cam struck across it, it started to break off the metal. On the right, the additive technology, the Aerospace Advantage, was able to stay in the metal and not allow it to break. The picture says it all right there. So here we've got a graft, and it took a lot of money and time to make this. But over here you've got your Moly, Moly B denims, organomolys. These are the products that most of your race oils are going to be, or performance oils are going to be making out of. You know, whether it's Mobile or Schaefer's or others, they're going to be using some Moly in their oil. Royal Purple, uh, Joe Gibbs. Yet over here we've got the PolyX. Okay, so when they had like a wear scar testing, all right, it was a Phalanx pin V block test for 1 hour with 500 pounds of load on it. Okay, the SynMax provided with the PolyX 58% more protection with less additive package used. Amazing. The other thing that's interesting is there's 3 diamond carbonates inside of the diamond like additives, which is basically for cold, medium, and then extreme duty conditions. It takes a little bit of time for them to soak in, about an hour. Once they finally soak in, you can see here in these cycles that in seconds of time down below, all right, that the coefficient of friction lowered to 0.14 coefficient, and that's pretty low. Moly is around 0.9. Here's an engine that was a super late model motor designed for the CRA series rules. It's 358 V8, 9-to-1 compression, and this is what we call a 4-barrel 390 carburetor motor. But with a special design, it's able to do 9,400 RPMs at 550 horsepower. Here's the deal. This is the camshaft. Now, there's 2 types of areas that we have on here. After 1,000 racing miles, the cam is still like brand new. You can look at the rollers, and it's like it wasn't even used. Furthermore, you can look at the slide areas of the roller uh, lifters in the slide areas where they go in the engine. They're not even barely touched. So this can be reused. You might say, Clayton, but I always thought on a camshaft it was on a solid lifter. Now we're going to get into that in a minute, in the presentation. But we also have to remember the little needle bearings and how much punishment that they go through as well. This is DLA technology in action. Another very important area is the piston skirt and the rod bearings. Okay, this is after 1,000 miles. Look at this skirt. It's like brand new. It's like it was never used. Why is that, Clayton? You know, it's because the diamond-like additive technology got into this skirt and it just protected it. 9,400 RPMs, that's a long time. Now, I know these bearings are coated here, but you can see they're like brand new and literally could be reused again if the engine builder would choose to do that. Again, here's the crankshaft. Here's a couple of areas. Number one, here's the end of the shaft. Literally, this is a very expensive crankshaft, by the way. Um, the end of the crankshaft is still like brand new. And here's the main journal. Beautiful, beautiful shape. And that's what we expect from the diamond-like advantage for motorsport. Now, this presentation is to provide the SynMax Performance Lubrication Advantage through data and facts and component historical performance, which has been performed with an LS2 race engine successful history, data, testing, and then also you will see information from a NASCAR solid lifter application. Now, the data information applies to universal applications found within automotive, everyday car, racing, extreme duty, commercial and industrial, and even the military. Because the diamond-like additives not only can provide protection and reduce coefficient of friction, but increased energy efficiency. All right. These theories also would apply to the gear products as well. Now here's one of our guys that we love a lot. His name is Lowell Bennett. He was a 7-time slinger champion, and Lowell Bennett here has been using our oil for the last few years. What we have, he had a left-hander chassis, super late model division, as I said, 7-time champion. And what we have is a Wagner LS2 race engine. The oil that he used was the 15W40 oil. Now this LS2 engine was the same engine that is also used in like the Robert Yates race engine for the NASCAR series. So it's the same LS2 type platform. So if you have that engine built by Robert Yates Engines, it's the very same motor that we have here, or close to the same design. Now this tear down was done by a very good associate of ours named Dan Tim at the time when he was manager at Wagner Automotive. Here now this was after 1,000 miles of racing. And you have to understand that Slinger is a very hard short track. It's on the gas, off the gas, on the gas, off the gas. Even though the bearings look good, now this was taken apart, it wasn't cleaned. You can see that the piston skirts don't even look like they were worn, okay? And this was 1,000 miles of racing at close to 600 horsepower. The other thing that you're going to see inside of this piston is internal cleanliness. Look how clean that it was. It wasn't a charred, mucky mess. Say, why is that so important? All right? It's because that oil that gets splashed in there, you see, it has to go through those holes to get into the oil rings, and then it has to go through and clean the piston pin, a wrist pin. So clean oil technology is important. Furthermore, if you were only going to have just a smidgen of an ounce of oil with all that heat, do you want to put the cheap stuff in there or the good stuff? Again, look at this piston skirt wear. So why is that so important, Clayton? Well, you could have a set of Mall racing pistons, MAHL, used like an Audi and Corvette and in the highest ends of motorsports, and they spend a lot of money on piston skirt technology and coating the piston. Well, the thing here is if you use these diamond-like additives and they soak into the engine and they soak into the piston skirts, okay, you don't need to spend all that money on there because you already have diamond-like additives that are lowering your coefficient of friction. So, again, regarding cleanliness, here you see the oil pan and then you can see the cylinder heads, okay, how well they were working, how clean they were. Say, why is that so important? Because oil also cleans other than cleaning, also cools the engine. So if your valve train and other components can be able to flow easily, okay, I guarantee you with this oil, you're not going to be spelling your name in varnish at the bottom of your pan. So we've come to the end of our presentation, and we showed you the graph data, we showed you a race engine, and we showed you laboratory magnifications. And so we're excited when you're able to use this technology yourself. You're not buying oil. You're purchasing liquid science and chemistry to the application. So this is Clayton Balmas, and I wanted to thank you for the time that we spent together. And I look forward to seeing you at our next session. And I encourage you to look at the other sessions that we have to bring more education. So we'll see you next time, and thank you for the time we spent. Bye now.